Welcome to Legends of Data and AI. Each episode includes inspiring and actionable data and artificial intelligence insights from global leaders across industries. Your host, Dr. Usama Fayyad, was the first Chief Data Officer at Yahoo and is Chairman of Open Insights and Executive Director of the Institute for Experiential AI at Northeastern University.
Welcome everyone to another episode of Legends of Data and AI. I'm Usama Fayyad, Executive Director of the Institute for Experiential AI at Northeastern University and Chairman at Open Insights. With me today, we're lucky to have Tina Eliassi-Rad, who's a professor of computer sciences at Northeastern University, where she's also a core member of the Network Science Institute and the Institute for Experiential Artificial Intelligence. In addition, she is affiliated with the Santa Fe Institute, working on complex systems. Before Northeastern, she was a professor at Rutgers, and before that at the famous Lawrence Livermore National Labs near Berkeley. Welcome, Tina, and thank you for joining us.
Thank you so much, Usama. Thanks for having me.
So, Tina, to get started, you have experience in doing, of course, AI, but machine learning in particular in many settings in research and academia. In your opinion, is most machine learning basically same set of algorithms applied across domains? Or are there major differences as you move from one domain to another?
So I would say, as you well know, similarity is in the eye of the beholder, right? So some people would say, look, algorithms like random forests and regression are very popular and are used across many different domains for many different applications. However, I would say that I've noticed outside of academia, properties like scalability or explainability or interpretability are more important. Now, some of your audience may say, wait a second, what about all this explainability in AI, the XAI? And I would say that just most recently became a first class problem. So one of the works that I did when I was at Lawrence Livermore National Laboratory was to find roles for people in complex networks. And I believe that if I was outside of Lawrence Livermore, I would not have paid as much attention to sense making. And perhaps you would just publish, well, you know, my algorithm found 5 roles, 1, 2, 3, 4, 5, right? Versus when I was working at the National Laboratory, that was not enough. It was not enough to just say, look, my algorithm beats other people's algorithms and I found 5 roles automatically. It was like, what are these 5 roles? And that actually made the work better. So there are similarities and then there are differences.
Yeah, no, can you share a story or two on how machine learning, data science was a key ingredient to success or made a big difference in our ability to achieve certain tasks that otherwise would have been very difficult or impossible to do?
Yeah, so I'll give you one story. This is work that I did with colleagues at the Catholic University in Leuven in Belgium in the mid-2010s, and it's about fraud detection. So in Belgium, they have their Social Security Administration where companies have to pay taxes to the government. And so they were interested in trying to find companies that don't want to pay their taxes. And the way that they get around that is they go bankrupt. And so then the idea was, okay, I have a social network of companies, of resources. Can I predict when a company is going to go bankrupt and for what reasons and where does that resources go? And so that was one of the cases in which we had to use machine learning, network science. And one of the things which is interesting is that when you are given a data science problem, in a way it's similar to a math problem. You have to dissect it. So if you think about fraud is uncommon, it's well considered, it's concealed, it's time evolving, it's carefully organized. And so if you think about all this, you're like, okay, well, it's carefully organized. Then there's a social network involved, so I should use something from social network analysis. Or it's well considered, so I should weigh the timing. So obviously a fraud that happened 10 years ago is not as important than a fraud that happened yesterday. It's time evolving. Should I look at it in minutes? So what is the temporal granularity, and also it's uncommon. So I have this huge class imbalance where the majority of people are good, but very few people or very few companies go commit fraud, and that it's concealed. So these people know about the system, about the context. And so whenever like I'm given a data science problem or a machine learning problem, I try to dissect it in terms of what is the context, where is the data coming from, and then seeing what approaches from machine learning are useful to solve that problem.
And the results in that case?
The result is actually the system that we developed is being used in the Belgium government right now. And so what we did was we looked at basically propagation of fraud in bipartite networks of companies and the resources. We looked at dynamical behavior. Compared to other baselines, we're able to detect up to 55% more fraudsters over time. And one of the key aspects was to basically downgrade past fraud and upgrade recent fraud. So that was this notion of dynamical behavior that you need to take into account. It was a lot of fun.
Yeah, and certainly it brings together kind of the relevance of things like network science, of having prior knowledge, of understanding the dynamics and the game theory nature of it, which is, you know, you're working against an opponent here who's trying to adjust as well.
Exactly.
You know, there are many examples of AI, and especially machine learning in AI, making things very possible in solving hard problems. But it seems surprising to me that there's little understanding of kind of the deep dependence of machine learning on data. Many people assume AI algorithms somehow reason about the task like humans do by drawing on prior or similar knowledge. How do you explain to the general public the very heavy dependence of algorithms on data? People have no feel for the fact that the level of detail required to do machine learning far exceeds what humans need when analyzing data for human consumption.
Yeah, excellent question. So I think part of it would be to tell them that machine learning algorithms are uncertain about their output, right? It is not that you are in this like rationalism state of mind where you are driving everything from first principles. It's that machine learning algorithms are learning from experience. And oftentimes when you learn from experience, data, you are uncertain about the outcome. And in fact, this is the part which is interesting. Is machine learning giving me knowledge, right? Is a machine learning system actually giving me knowledge if it has uncertainty? And unfortunately, when we talk with the public, we don't translate this issue that there's uncertainty. So when like risk assessment systems are being used, and whether it's a social facing situation or not, like for example, hiring or school assignment, usually it's like on a scale of 0 to 10, like a pain scale, right? And you're like, oh, the risk of Tina, not giving the loan back, right? Defaulting on the loan is 9, but you never tell the person that like maybe the algorithm is only 50% sure, right? And then because we're not good at communicating probabilities and uncertainties. And I think that would be one way of telling the general public that these are not objective algorithms that know all, so.
And the other thing I've seen is many people assume implicitly somehow that, when a human approaches a prediction problem, they have a lot of prior knowledge, they understand the domain. They don't realize that these algorithms have to build up everything just from the data. They typically have no knowledge whatsoever and no sense of what's likely to happen, what do the events mean, all of that, and it has to be built up from data. And that's a very difficult thing to imagine. Go ahead, sorry.
Yes. Yeah, no, sorry. Yeah, and I think part of that is also our fault in terms of how we educate our students. So within like machine learning, data mining, or artificial intelligence, oftentimes we come in when data comes into the system and not thinking about what is the process that's generating the data, right? What kind of dependencies actually matter, right? So if I give you commutes of different passengers and I tell you predict the subway system for me, the fact that somebody has to transfer at a particular place to go to another location means that I need to take temporal dependencies into account, right? And so unfortunately, we don't teach our students that, look, you need to care about where this data comes from, the distribution of the data, the process underlying it. And so there's that disconnect, not just for the general public, but also for our students.
Yeah, absolutely. Which actually this brings us to this whole topic you're introducing that you're calling just ML, for just machine learning. Perhaps you can share with us, how do you define just ML, and maybe, why and how did it come about? What's, so to speak, what's the origin story of your just ML project?
Right. So the name came from the fact that there was this period where like people were afraid of machine learning. And so it was like, look, it's just machine learning, like, don't worry about it, right? But then on the flip side, machine learning is being used in these high stakes situations like criminal justice, etc. And so you should care about how these algorithms handle the marginalized people in our society. And so the origin story was that at the time, the director of the Safra Center for Ethics at Harvard, Danielle Allen, asked me to come and give a public lecture about AI and ethics. And so that's how I got started, and I needed a good title for the talk that then became the title of this project. And so it was lots of fun. This was about 4 years ago, to just look into what people care about in terms of ethics in AI.
Yeah, and I always love that kind of double entendre on just, as in simple, and just as in justice. And definitely an important area, and definitely brings out kind of many other dimensions you have to think about, rather than just applying algorithms and seeing what a predictive model gives you. Machine learning is critical to successful applied AI, and therefore data becomes a primary consideration. How do we think about data as we start thinking about doing just ML? Any special considerations, anything we need to worry about when it comes to the data, which pretty much drives the whole AI application?
Yeah, so I like to think that if we're using data for especially these social facing situations, these kinds of just machine learning applications, that each data set should come with a data sheet. This is the title of a paper that Timnit Gebru et al. Wrote back in 2018, and it was just published, Data Sheets for Data Sets. And it's like a long form birth certificate, right? Where you talk about what's the motivation behind this data, how was it composed, how was it collected, what kind of pre-processing did you do, what are its uses, what are its distributions, what are its maintenance. In fact, when I was first reading it, it reminded me of the knowledge discovery and data mining process that you had in your book, right? That, look, when you get the data, you have to process it, you have to clean it, right? And that's a whole part of it. And then you can do the fun stuff with data mining and machine learning and etc. And so having this kind of a long form birth certificate with data would be very helpful, because then you could see how the data was collected. So if I need, for example, more diversity in my data set, if I'm doing image recognition, and I find out that you went and collected all the people who are dark skinned in Atlanta, and you paid like the homeless people and the students $5 each to collect their data, then it's like, wait a second, maybe I shouldn't be using that data. This actually happened with Google. They were like, oh, we need to diversify our data set for image recognition. They hired a subcontractor that went to Atlanta and looked for Black people who were either college students or homeless people, gave each $5, had them sign a consent form, and took pictures of them, right? Which is, of course, completely like wrong. And when this hit the news, of course, Google blamed the subcontractor, right? So you need to just be more mindful of it from the very beginning and think about privacy. And so these kinds of like documentation, I think, really helps.
Yeah, no, this is very important, especially kind of understanding how completely dependent is that AI application, and the outcomes that come out of it through machine learning are on data, and what's in or not in the data. And in fact, probably a lot of people are familiar with the fact that because of this line of research and some paper publications, Timnit Gebru got fired from Google for kind of investigating these issues, which are important and core, but companies sometimes try to hide from them, which is why, again, yeah, go ahead.
Yes, yeah, absolutely. And if I may, this is not just the social data, right? Like a lot of people think, and of course they're true, that the rise of machine learning now has to do with all the data that we provide, right? On Twitter, on Facebook, on LinkedIn, on Google, Yahoo, etc., right? But this is not just limited to that data. So the oximeter data, these little devices that you can buy at CVS, at any kind of pharmacy, that measures the oxygen level in your blood, we know that that's not good for dark-skinned people. We have known this since 1950s. Just imagine all the data that has been collected over time and has been fed into this health informatics, machine learning for health and medicine, right? And it does not work for a group of our population, for a subgroup in our population. And that it's not like document. It was crazy to me that this was known since the 1950s and just people don't care.
Yeah, amazing. I mean, on that topic, people don't think much about ethical and justice issues in traditional pattern recognition, in statistical analysis, and say, common regression. Why, you chose to call it just machine learning or just ML, yet, I never heard before, somebody saying, well, this is just regression. What is unique about ML in this context that kind of got you over the threshold to say, look, we got to label it with the justice label up front?
I feel like in a way, it's like prescription drugs, right? Machine learning works well for certain groups within our population, as we were just talking about, and doesn't work well for others, right? So if I don't have data on the elderly, then my machine learning algorithm will not predict well on the elderly. Similar to prescription drugs, where it's targeted for a particular group of people, and they have adverse effects, right? Especially nowadays, right? So the notion of just machine learning is because if the machine learning algorithm is being used on somebody who is not within the population that the machine learning algorithm learned about, they may do worse on them, and they often do, right? This is what the gender shades paper that Joy Bugliomini did with Timnit Gebru, that these state-of-the-art commercial facial recognition systems were not doing well on darker skinned people, especially darker skinned women. And so I feel like, again, it's kind of like we need these warning labels, these kinds of, similar to what we have for prescription drugs. So that's where this notion of just machine learning comes from.
That's a great analogy. The warning, the algorithm comes with a warning label, or the model, the predictive model coming out of it. How does, in your opinion, just ML contribute in kind of establishing trust in AI algorithm, getting people to trust what AI algorithms are doing?
Yeah, I think it doesn't. We try to hide the complexities, right? And I think part of it is within our community, where it's like, you always talk about the good things about your algorithm and the model, and not the limitations, right? We never talk about the hyperparameters that really affect the outcome of the model, right? We talk about how well I can learn the parameters, right? And so, like, for example, we often don't talk about that, oh, this system will only work for this subgroup. Again, I'll go back to this. Charles Isbell's NeurIPS, the Neural Information Processing keynote this last year, actually talked about how you can't escape these hyperparameters. And as part of his keynote, he talked with Ayanna Howard, who's now dean at Ohio State University. And Ayanna Howard was like, when we build a bridge, we build it for everybody. We don't build it for just white people, right? So then when I go over a bridge, I trust that bridge. It has standards, it has specifications. So I think, like, if we want machine learning to, for the public to trust machine learning and trust AI algorithms, it would be that there is some specifications that AI algorithm meets, right? And then at least you can say, outside of this, then perhaps you should not trust it.
Yeah, well, it's a tricky topic, but an extremely important one, which leads us to this whole area of responsible AI, which is getting a lot of attention. Many enterprises are worried about unintended biases and issues of fairness. They want to avoid them, but they don't even know that these things are happening. Yet no one really understands what the issues are, and no one knows what professionals who are to drive these efforts must know or be trained on, including universities don't know what to train on, right? And we're still trying to figure it out. What's an enterprise to do in an environment like this?
Yeah, I think the thing to care about is the marginalized people in your society, right? So the marginalized people in your society are going to use your products, and how well do your products work on those marginalized people? Some in your audience may know LaTanya Sweeney, who's a very famous professor at Harvard who worked on who worked on privacy, so when she moved to Harvard, right, there was this journalist that came to interview her, and she was going to show him a paper of hers. So she goes to Google and searches and finds her paper, but then the ads was talking about LaTanya Sweeney arrested, so on and so forth, right? And so then the journalist says, wait a second, forget about your paper. When were you arrested, right? And it's like, I was never arrested. And he's like, well, but Google said so, right? And then the journalist, who was Italian American, said, oh, it's because you have one of those black sounding names. And she was like, what do you mean? And then they went to Google and they typed in LaTanya, and a lot of the pictures that came back were pictures of African American women. And when she typed Tanya, that was not the case, right? So that's what I mean by, like, how do your products work on the marginalized people in our society? Because the privileged people are going to be fine anyway. So obviously, there's been a lot of discussion about diversifying your groups, having diversity of thought, not so much, like, oh, well, I have all of these people who went to Ivy League schools. That one studies philosophy, that one studies computer science, but actually diversity from the population, from the marginalized people in our society, and how do these products work for them?
Yeah. And I know you've often talked about the importance of even making sure the team of developers is diverse enough, because you get these biases introduced if it's a bunch of white guys coding up some algorithm and have no other input or no other knowledge of kind of what's embedded in their heads.
Yeah, exactly.
And so that brings up the issue of talent. I mean, it's already difficult enough to find talent in this area of AI, data science, machine learning, advanced analytics. And companies and employers in general are finding it very challenging to find candidates. If we add in the constraints of ethical issues and just machine learning, it would seem to make the challenge harder. How do you think about this? But it's necessary, of course. But how do you think about this pragmatically?
Yeah, I feel like, the days of, oh, I'm just going to be the algorithms nerd in the corner are gone, right? Because you could develop a system, and especially now with all this talk about democratization of data science, right? Which is fine. But the thing is, if you don't know how those algorithms may be used, then somebody can get money and download that software and run with it, like the Clearview AI example, right? I believe CEO is about 20 something. He received some funding. He scraped images, publicly available images from the web. And I think he's using TensorFlow or something to do face recognition, right? And it's amazing who some of his clientele are, like high schools. Like, why would a high school need this, right? So there's no oversight. There's no like professional norms here also, which very much hurts us. And so I know that, like, for the people like us, it's a lot easier to sit down and talk about algorithms. But given that those algorithms are going to be used, we just have to use that part of our muscle, right? And think about these values up front. In fact, going back to LaTanya Sweeney, she says that if you are a business, right, and at the very end, you think about the ethics, it's too late, right? Yep. You really need to think at the very beginning, what are the values, what are the norms that you want your technology to have, and built it in, as opposed to at the very end kind of ethics washing or, that kind of a jazz.
Yeah, and as many, I mean, one of the biggest justifications for it, as many banks and manufacturers have learned, it's either pay now or pay later much more when you get penalized and sued and all of that stuff. what advice do you have for companies, large enterprises or new startups, in terms of how to think about machine learning and just machine learning? Like what's a generic, short, quick advice?
Yeah, I guess two takeaways. One is care about the uncertainty in the machine learning and the AI system. Ask about it. The machine learning AI systems are not certain. Don't let them dumb it down for you. And two, care about how your products work on the marginalized people in our society. Because exactly as you said, you either pay now or you pay later. So those are the two takeaway points.
Great advice. In conclusion, Tina, my last question to you, and I would love to go on with this discussion for much longer. In your experience, just thinking generally here, what's missing in the world of AI, machine learning, data science, and data that would make it more of a safe and mainstream activity that all sorts of companies and organizations can benefit from, right? Right now, there's very few players who really benefit from the technology. Everybody else is watching and wishing and not knowing what to do. But what do we need to do to make this more mainstream, to democratize it correctly?
Yeah, so there are no quick solutions, right? I feel like to make it better, we need more representation. To have more representation, we need to start young, much younger, right? In elementary schools, in middle schools, and go and talk to those folks and encourage them to pursue STEM. So when I was a professor at Rutgers University, I went and gave a talk at Girls Inc. that was running this camp in Brooklyn. And I was supposed to talk to middle schoolers. And these are all middle schoolers that are coming from the marginalized families in our society. I was extremely nervous, like talking to, like I walk in, they all want to be Beyonce. I want to be Beyonce, who doesn't want to be Beyonce? But like be able to tell them about, for example, epidemics on a network, right? Show them a dating network in a high school and say, okay, well, we have 10 condoms. Who do we give the condoms to stop the spread of a disease? And even though they don't know the math, they know where you would give the condoms because they know centrality, right? They know this notion of, oh, this person is dating lots of people. And so we need to protect that person. And, and so it was fantastic to be able to talk to them and encourage them to pursue science. And this kind of thing needs longer term mentorship. So this is like a 25-year project, right? Where you start young and you build up that representation.
Yep. And, great examples of introducing, influencers in a network and all of that. And it just shows it's possible to do it if we approach it right. Tina Eliassi-Rad, I want to, on behalf of the audience, I want to thank you for taking the time and sharing your insights and learnings. I appreciate your attempts to kind of do things right and to simplify them and making them more understandable. So thank you, Tina.
Thank you very much, Usama. I enjoyed it.
Thanks, everyone, for listening to yet another episode of Legends of Data and AI, and join us in the forthcoming episode that will be announced shortly. Thanks.
Thanks for listening to Legends of Data and AI. We hope you enjoyed our deep dive into the world of data and AI. If you're keen to learn more about making data and AI work in the real world and in any organization, join us next episode and subscribe to the podcast. As always, you can head over to open-insights.com to sign up for our email list, learn more about the work we do, and have access to data resources. See you on the next podcast.